Why are degrees of freedom important for robotics? Imagine trying to reach for a glass on a cluttered table. You need your arm to move in just the right ways to grab it without knocking anything over. That's where degrees of freedom come into play in robotics. Degrees of freedom are the number of independent movements a robot can make. Think of each joint as a way the robot can move or rotate. For example, a joint that spins around provides one rotational degree of freedom. If a robot arm has 6 joints that can move independently, it has 6 degrees of freedom. This number tells us how flexible and capable the robot is. In manufacturing, robots with more degrees of freedom can reach around obstacles or into tight spaces. They can position tools or parts in very precise ways. For tasks like welding or assembling tiny electronic parts, high degrees of freedom mean better control and accuracy. Robots with fewer degrees of freedom are simpler and often used for straightforward jobs like moving objects from one place to another. For example, a Cartesian robot has 3 degrees of freedom for moving along the X, Y, and Z axes, perfect for pick-and-place tasks. But for complex tasks like painting or intricate assembly, robots with more joints, sometimes up to 7 or more, are used. These extra joints give the robot the ability to tilt, rotate, and position its tools exactly where needed. The more degrees of freedom a robot has, the more adaptable it is to different tasks. However, more joints also mean more complex control systems and programming. Engineers need to balance the robot's capabilities with how easy it is to operate and maintain. In industrial settings, understanding the degrees of freedom helps in choosing the right robot for specific jobs. It also influences the design and cost of the robot. Robots with high degrees of freedom are more versatile but can be more expensive and requiring advanced control software. So, in manufacturing, degrees of freedom are a key factor in how well a robot can perform, how flexible it is, and how efficiently it can be used. They shape the robot's ability to do everything from simple material handling to complex assembly tasks. Knowing this helps engineers build smarter, more capable robots that meet the needs of modern factories.